Hi everyone, it's Liam here. I wanted to give you a little bit of video feedback on how we answer the A-level exam that you've just done. Now, obviously, the front page talks about the scientific calculator. It's worth having a calculator in there. There's nothing too major with the equations you're going to be working out, but yeah, it makes life a little bit easier. So if we go through to question 1, so it's talking about a football player at the knee joint. Identify one of the quadricep muscles. So obviously we just need to name one of them. So we don't need to name all four, just name one of the four quadricep muscles. And then the main part of the question, outline the functional and type of contraction used during the preparation execution. Now, functional role, what we're talking about there is agonist or antagonist, so the role that it plays throughout the movement. And then when answering this question, it's really important that we say during the preparation phase, and then we talk about the functional role and the type of contraction, and then during the execution phase. So we need to make sure we clearly set out that answer. If you move on to question 2, question B, sorry. Now, again, we haven't taught you how much blood goes to the skin and what percentage of blood flow really gets to the skeletal muscles at those points. But what you can do with this question is obviously you've got the total down there, and you just need to find the missing amount there. So don't be thrown by these sort of questions because the answer is kind of given to you. So obviously it's 5,000 millilitres, so we need to work out what the difference between all these are, and then 100%, and again we'll find out what the difference is there. So all we need to do is just put in the missing value, and I would recommend with the 5,000 like putting a milliliter for there and putting a percentage next to there so we know we're clear with the number that we're using. And then explain how the changes occurs. So the distribution of blood occurs. What we're going down there is the vascular shunt mechanism. So we need vasodilation, vasoconstriction. When we're talking, if we use them terms in the skeletal muscle, we don't talk about the opposite happens at the other organs. We like describe the whole process at both sites. So it's really important we do that. On to question C. So the mechanics of breathing. How they change. So the mechanics of breathing, remember we're looking at muscles that contract, the movement that occurs, the pressure that changes, the volume changes and how air moves. And with this question, because we're talking about during exercise, we need to be bringing in the additional muscles that are caused. We need to make reference that there's a greater volume change, there's a greater pressure change. So we're using adjectives to show that we're showing the change there. And then again, with the process of the gaseous exchange during exercise to resting conditions, again, we need to mention what the difference is. It's higher, it's lower than they were there, and then what the impact is. So the result of that greater diffusion gradient, what impact that would cause, and obviously we need to make sure we get 4 different marks on there. In terms of question 2, so now we're going into a different part of the course here with obviously the orange pages of the book. So outline the timing of pre-event meals. So obviously it's looking at a couple of different bits there. So obviously we can look at the pre-match meal. We can mention like when you would have the pre-match meal and the composition, what it would take part of. But also you've got the immediacy, so what you're eating in the changing room immediately before a game and how that changes. So maybe carbohydrates is going to be a big part of your answer, but how the different carbohydrates will be taken during those different times. And again, we're looking for 5 marks there. On to B then, to the aerobic capacity. Evaluate the benefit of the different physiological adaptations made by the muscular and metabolic systems. Again, what we need to be doing here is actually identifying what the physiological adaptation is and then how that then benefits. So for each point, we're trying to develop it into this happens as a result of aerobic training, and this is how performances affect. So we're talking about like the muscular system, so what specifically happens to the muscles, and then metabolic, that's all about the generating the energy. So where does that energy come from, and how does that affect us? So obviously we've got 4 points in there. As we move on to C, so describe using practical examples the following types of strength. So we've got 6 marks. There are 3 strengths here. So where we're picking up our marks here is we need to define each type of strength, or use a description of what that strength actually means, and then give a specific sporting example. So remember, gymnastics isn't an example. Maybe the first one, performing a crucifix on the rings in gymnastics, is the example. So we need to really drill it down to the actual moment when we're showing that. So if we're just putting sports down, we're being a little bit too vague. And then on to D with the methods of testing. So it gives you an option for one of the two flexibility tests. And we've got to be really careful here that we look at the bold in the writing. So it's one test. We need two advantages and only one disadvantage. So we're not wasting our time maybe putting one advantage, two disadvantage. We're going to lose marks there. So with the advantages, remember, we're looking at the time to do the test, the accuracy, the kit and equipment we needed, the cost, how long it takes. And then for each of the two tests, we can select one, and remember it's two advantages and two disadvantages. Moving on with the javelin thrower, again, some students can get thrown with that. Get thrown by the questions, pardon the pun there, of javelin. They've never thrown a javelin, or they've done it maybe once in PC, don't have an understanding. So if we ignore, the javelin thrower, we know a javelin thrower needs to throw for distance. It's looking at essentially how flexibility affects, I suppose, the strength and the power of the athlete. So it's drawing those links there. If we remember back to the flexibility chapter, we looked at the adaptations that are caused and what impact that has. And obviously greater flexibility does give us greater strength. So on to question 3, and now we're looking at the biomechanics, and this again worries some people, the biomechanics, because it can be quite a little bit confusing, and it's stuff we maybe not know naturally. So with this first 3-mark question, apply Newton's second law of motion and show how a hockey player may maximise the ball's acceleration. Now, with these questions, applying Newton's second law of motion, now the first thing we need to do is actually say what Newton's second law of motion is. So we recall that, what is the law actually saying? We then, the second part of the question, clearly we need to apply it to when a hockey player may use that law. So when in a game of hockey, may they look to apply Newton's second law of motion, and then how they're going to maximise performance is what is going to happen as a result of them applying greater acceleration to that ball. So it's kind of a 3-part question. What is the definition? How would a hockey player use that? And then what impact would that have on their overall performance? Moving on to II, this is where the calculator might come in handy. We need to calculate a force, and again, people can be thrown by equations. If you remember, F equals ma, so force equals mass times acceleration. This is a 2-mark question, so don't just go into working it out, giving your answer. I would recommend going down, writing out the equation F equals ma, substituting your numbers in, so 0.16 multiplied by 30 ms squared is how we're substituting it, and then coming up with the final answer, and remembering to give the answer as with the units. So you can do kilograms per meters per second squared, or obviously we know force is measured in newtons, you can give it as newtons. And then with the lever system, again, it's asking you, again, a couple of parts of this question. Identify all the components of a lever system. So we need to make sure we say what the lever systems are, and then we need to order them in the order of a first-class lever. So the first thing we need to do is say a lever system consists of this, this, and this. We need to say a first-class lever is ordered in this way, and then we need to say, give an example of when we would use that in sport. So like the 4-mark question, so we need to make sure we're covering all those bases and doing it structurally. Moving on to the next one, so force plates. Again, a little bit of a harder question, this one. So it's 5 marks. It's quite a small part of the specification. So we need to kind of say when we would use force plates. So obviously we use it for measuring like walking and running forces, looking at footwear technology, looking at the balance of an athlete, and how force plates are used to enhance sporting performance. Clearly they can be used in order to generate force when taking off. They can use to injury prevention, to see how runners are landing, and they can use to sort of build specific footwear to help support performers going through that. So that's quite a difficult one. So a couple of examples of when we use them and how we use them, and then 2 or 3 points about how they enhance performance, and we've just gone through them there. And then onto the Fosbury flop technique. Again, quite a tricky one, this. Looking at centre mass, so the first thing we clearly got to do is define what the centre of mass is. So we get off to the mark with 1 mark there and describe the changes in the position of takeoff during flight that maximise performance. So we need to, again, state in our question during takeoff and then apply how the centre of mass is affected there. And then the final part of our question, during flight, we need to explain how the Fosbury flop techniques enables the high jumper to get over the bar. So it's really important we set out the questions in those ways. And then moving on to section B, which is the 10-mark question. These, again, it can be tricky, but if we kind of break this down, if we look at, there is actually 2 questions in here. So it is seen as one 10-mark question for question 4, but there are actually 2 questions within that. So explain the physiological adaptations as a result of a flexibility training program, applying them to a sporting activity of your choice. And then secondly, evaluate the use of practical examples, the structural and functional characteristics of fast oxidative muscle fibers. So we're not having to link those 2 statements together. We're really answering 2 questions within one. Now, with the flexibility, obviously we did a revision session. Hopefully you had a chance to watch that. The adaptations, there are very few adaptations to flexibility training because there's not much we can affect within that. But again, what we need to be doing is saying what the adaptation is, so maybe like increased range of movement at a joint, and then how that affects a sporting activity of your choice. So obviously increased range of movement gives us a reduced risk of injury, but it also allows greater force to be applied. For example, when, and again, going back earlier, we need a specific example. So again, gymnastics and football are not examples. When a centre forward takes a shot, they can apply more force and give a greater chance of scoring a goal. So we make sure we're giving very, very specific examples there. So we need 3 or 4 of the adaptations. And then if we move on to the second one, evaluate using practical examples the structural and functional characteristics of a fast twitch muscle fibre. I'll be recommending here to make sure we give both structural and functional, so we cover both bases, so we answer all of the questions. So clearly we could do 4 or 5 structural characteristics, but if we don't do the functional, we've not really answered the full question. So maybe 2 or 3 structurals and 2 or 3 functionals. And again, what we need to do here is identify what the structural characteristic is, whether it is high or low, or many or few, or that kind of adjective we used within a fast oxidative muscle fibre, and then what impact it has on sports. So, for example, we know there's quite a high capillary density of a fast oxidative muscle fibre. That will be a structural characteristic. This allows greater aerobic respiration, which allows us to reduce waste products in a muscle. Therefore, we can exercise, we can run for longer without getting tired in a marathon, for example, or a 400 metres, 800 metre, pick your event. So again, with that 10-mark question, it is, it can be daunting with that, but as I say, we need to deal with it, maybe draw a line on your paper, here, so we can see that there are 2 kind of questions in there. Well, hopefully that explains it. What we're going to do now is share the mark scheme with you, so hopefully you can review your answers and you can see where those questions are coming from. So thanks for listening, and hopefully see you.